Let's consider manually operated switches. Switches operated by a person's hand typically. So these are things that allow users to give input to the machine. Start button, stop buttons. Things that are supposed to apply brakes. Whatever the case may be, these are typically control buttons. The way these work is that, well, it depends. There's the button and the switch are two separate parts most of the time in industrial switches. And the button part is something you can change out from the switch because you might want a different color or a different configuration to indicate what the button does. But the switch on the back side, well, the switch on the back is not necessarily just one switch. Often there's more than one switch. So there can be multiples of these types of switches that I'm going to show you on one button. That is possible. I've seen buttons that could accept up to 8 switches or so. And those are not common. Most of the time a switch has, 2 or so, or a button has 2 or so switches on it. But there's a normally open type of switch on the left-hand side. This is where the contacts are not touching anything. There's 2 wires basically, and the contacts are not bridging those two. But when you push the button, then the switch changes state and closes. That's a normally open switch because in the normal configuration the switch is open electrically, which means that no current can flow through it. There are also normally closed switches, as you see in the next image. And this is a switch where the spring applies force onto a bridging connection, essentially, that connects 2 wires within the switch, or 2 contacts within the switch. So unless you push the button, current can flow through this. So the first type, normally open, current won't flow through the switch unless you push the button. The next time, current will flow through the switch unless you push the button. And then there's a break-make type of switch, which these are not as common, but they are useful in some situations, where there's essentially a normally closed set of contacts that break so that neither set are open, and then finally when you finish the full stroke of pushing the button, the other set of contacts make. They bottom out, they conduct power. There are selector switches, which are a little bit different. The switch themselves are not that much different, but what's different is the way it's actuated. Instead of pushing the button, the user rotates it. And a lot of times the way these work is you'll have essentially a break-make type switch where the rotator just moves it from set A connected to position 2, where both are broken, to position 3, where where the lower 2 make, where B contacts are connected. And so the truth table here shows us in the various positions 1, 2, and 3 of the selector switch. We've got contacts A connected in position 1, contacts B connected in position 3, but in position 2 nothing is connected. So this is a pretty common type of actuator and switch as well. There are also dip switches, or dual inline package switches. Now these are typically not put out for a user to turn a machine on and off. These are usually fairly small. In fact, they're so small that a lot of people will use a tool to move them back and forth. Sometimes they're rocker arms. More often than that, they are little push switches, and they are usually together in packages of 8 or so. And these are just binary switches. They're on or off, just like all the switches we've talked about so far. And a lot of times these are used for options, for setting up particular configurations of something. For example, I have an air handler in my basement that heats my house, and obviously it's not an industrial piece of equipment, but it's kind of like one, in that there is a circuit board on it that controls the fan. Because when my thermostat kicks on and asks for the fan to run, the fan will actually run for a little bit of extra time after the request from the thermostat has gone off. And that's to make it, to make the system more efficient and so forth. But there are other options and things on the board about the maximum flow rate that the fan should blow through, the amount of time that the blower should run after the system has, or after the request to it has shut off, after the fan request has shut down, and what options are installed in it. So on that circuit board there's a set of dip switches like this, and typically I have to refer to the manual if I want to change anything and see what the switches do. Sometimes these switches will have printing, what's called silk screen, on the circuit board, like you see in this picture in the lower one. You might be able to make that out. It says RC0, RC1, all the way through RC7. These are just things that are printed on the top of the circuit board to indicate what various components are and what they do. Now often there's not enough space to have a full description of what the switches do, so often you'll have a manual with a piece of equipment that explains the different configurations of these switches and what each switch does or each grouping of switches do. So these are fairly common. They are for options typically, and they are not switches that commonly would be switched on and off every day. One thing to note about this type of switch, however, is that it is a so-called toggle switch. It's a switch that when you put it in one position it stays there, and that is in contrast to standard push button type switches where there is a spring return, so that they are momentary switches. They change back to their default configuration when the user releases them. Now obviously the rotation selector switch that we had before most frequently stays in position and acts as a toggle, but sometimes that type has a spring return as well, so there is a default switch location or switch position, whereas it's understood that push buttons typically are spring return, and so they have a default position of open or closed, or the switches associated with them have a default position of open or closed.